Hey guys, Midecali here. Welcome back to my YouTube channel. And today we are going to be looking at Ohm's law, right? So Ohm's law states that voltage across a resistor is directly proportional to the current, right? So which is the same thing as V is equals to I, our Ohm's law. So we could go further by making I the current the sort of formula by saying that I is equals to V over R. We just divided through by R. Equation 2. We could also go further by making R the sort of formula by dividing both sides by I. So here we made resistor the subject of the formula, we made current the subject of the formula, and here we made voltage the subject of the formula. So if you look at these two equations, we can input it into power, which says P is equals to V times I. We could either substitute our V or substitute our I. So if we substitute our V, we have it as IR times I, which is equals to I squared times R. One equation. Or we could substitute our I by saying P is equals to V over V times V over R, which P is equals to V squared over R. Another equation for power. But let's leave this. I don't think we need this now. Now let's look at our resistor and conductance. Now let's look at our resistors and conductance G. Resistors SI unit is ohms and conductance is inverse of our resistor. So if our resistor is equals to V over I, right, our conductance is equals to our conductance G is equals to I over V. Why? Because conductance is equals to 1 over R. Measured in mu, which is MHO, and measured in ohms. Now let's go further. Now let's look at resistors when they are in series. So this is a resistor. These resistors are in series. So if this is our R1 and R2, this implies that R1 plus R2. And if these resistors happen to be in series, R1 and R2, this would be 1 over R1 plus 1 over R2, whose SCM is R1 times R2. That's R2 plus R1 inverse, which is equals to R1 times R2 over R1 plus R2. This is series and this is parallel. Remember that I told you that G, which is conductance, is equals to 1 over R. So for resistors that are in series, in series, because it is inverse, we don't do this. What we do is 1 over R1 plus 1 over R2, which is equal to inverse of this, right? Sorry, inverse of this as well as inverse of this we did the other time, so which is equals to R1 times R2 over R1 plus R2. Same thing goes when they are in parallel. You do the inverse of what you do for a normal resistor. Here you say R1 plus R2. Don't forget that this is this and this is this. Resistors, conductance. Thank you very much, and please make sure you subscribe.